Okay, so this is section 1.1 in your textbook, very beginning of our grade 9 academic class. We are looking at, first and foremost, addition and subtraction of mixed numbers. Alright, so we have a problem. All the examples I'm going to do are going to be straight from your textbook, okay? So if you do miss a class or you miss a section, you can just use the textbook. Please do so. As you guys get into university, you'll find that your textbook will be probably your number one resource. Okay, assuming you have textbooks at that level, you go into engineering, you will. So please make use of them and follow the examples in them. Get used to reading the examples in the textbook and following them. Okay? Because for one, they're drawn a lot neater than I can do so on the board. And also they go through a tremendous amount of steps. So, the first question, it says, Elisa and Greg plan to travel from Canada to Italy for March break. Dawn is driving to her aunt's in Ottawa for March break. According to a travel website, Dawn's trip should take 4 hours and 36 minutes. And at the time for Elisa and Greg, we can see there is on a map on page 8 there in our textbooks. So I've drawn it out here. They're flying from Toronto first to London, England, which is going to take them 5 hours and 3/4 in an airplane, and then they're going to drive from London to Rome, which is going to take them 2 hours and 1/3. This is pretty accurate. I think this would probably be a little bit longer, given some of the traffic they might run into. Okay, so the question then tells us also that Dawn is going from Toronto to Ottawa, and it gives her time in 4 hours and 36 minutes. Then it asks how much longer is this trip going to take than this trip. So there's a couple of steps we need to do first. First thing we have to do is to add these two numbers, right? Because we want to get the total time for Lisa's and Greg's trip. Once we have those two numbers added, the sum of those two numbers, we then want to subtract Dawn's time. That will give us the difference, or how much longer. Okay, so there's a few ways we can do this. The first one they show us in the textbook is by leaving the fractions in mixed number form. Okay. For addition and for simple fractions, this tends to work well, especially for addition. Okay, when we get into subtraction, you'll see that we run into some issues here when we try to start subtracting mixed numbers. But for addition, it works quite well. So I'm going to take the two whole numbers and add them separately. So 5 plus 2. And then I'm going to take the two fractions and add those separately. So if I add 5 and 2, I get 7. And 3/4 and 1/3. To add those, of course, I need to find a common denominator. So I need to multiply the denominator I multiply 4 by 3 to get 12, and 3 by 4 to also get 12. That gives me a common denominator of 12. So I'm going to have 9 12s plus 4 12s. Alright, so we're going to move up here. So that gives me 7 plus 13 12s. Okay, now we could write this, we just combine the whole number and the mixed fraction together like that. Or this is not correct because we have two kind of fighting formats here. One is an irregular fraction and the other is a mixed number. So what we actually want to do is to convert this mixed number into, this irregular fraction into a mixed number. So we actually have 7 plus 1 and 1/12. Okay. Any questions on how to go from 13 12s to 1 over 1/12? So I need to review that? No? Okay, because we know that 12 goes into 13 once, and there's one remainder. So now our final answer then would be 8 and 1/12. Alright, so that's adding mixed numbers separately. The other way we could do it is just to first convert them into irregular fractions. Okay, and a irregular fraction is when the numerator is greater than the denominator. Okay, in order to do that, remember we need to multiply 5 times 4, which gives us 20, and add the existing numerator. So that gives us 23. And the denominator stays the same. So we have 23 over 4. Doing the same thing to this mixed number, we'll have 6 plus 1 is 7 over 3. Okay, so now we have two irregular fractions. Again, we want to find a common denominator of 12, so we're multiplying both by the opposite number here. So we get two numbers over 12. A little bit bigger, but still not a problem with our calculators. It shouldn't be an issue. We have 69 over 12 and 28 over 12. We add those up, we get 97 over 12. Dividing 97 by 12 gives us 8. Okay, with one remainder. Any questions there? Personally, if it was up to me, I wouldn't even show you this one. I'd probably just show you this one. Okay, it might take a little longer for some of the simpler problems, but it's guaranteed to work. Okay, and you can use it for any problem. Matthew?
With the second strategy, would you find any problems when you would be doing subtracting?
This one or the first one?
The second one.
Second one, no problems. No. But the first one we will, and I'll show you that now. So now that we have the total time for Elisa and Greg, so Elisa and Greg we know are going to take 8 hours and 1/12. We need to find out the difference for Dawn's. The first issue we run into with Dawn's time, however, is that it gives us to us in hours and minutes. It's not good because we're dealing strictly with hours, right? For the first example, we're not dealing with minutes, so we need to tackle that issue of having minutes. And this happens a lot in word problems. Sometimes we have a difference in units. So the way to deal with that is we have 4, and we convert the minutes to a fraction. So we make it 36 over 60. And it's 60 because there's 60 minutes in 1 hour. Okay, that's why we use 60. So that gives us a fraction of an hour, right? 36 over 60, that's the fraction in an hour. Okay, we can then reduce this to 4. 6 into 36 is 6. 6 into 4 and 6/10, which actually can reduce further. 4 and 3/5. All right, so we have these two numbers now. This is Dawn's, and this is Elisa and Greg. All right, so now we want to know the difference. How much longer did it take Elisa and Greg than Dawn? So what will we do next, McGill? We want to know the difference.
Subtract 8 and 12 from 4 3/5.
Yeah, the other way around. You subtract this from that. Yeah, I know what you mean though. Yeah, we're subtracting 4 3/5 from 8 and 1/12. So, in order to do that, we do this. Minus 4 3/5. So again, there's two ways we can do this. We can subtract just the whole numbers and then subtract the fractions separately. So let's go ahead and do that. So we have 8 minus 4. And then we have 1/12 minus 3/5. Okay, so 8 minus 4 is just 4. 1/12 minus 3/5. We need to find a common denominator. If you don't know the common denominator, for the lowest common denominator, you just want to get a common denominator and reduce later, you can always just multiply the denominators by themselves. Okay, which in this case happens to also be the lowest common denominator, but it's a nice quick way to do it and then worry about reducing later. So this gives us 1 times 5, 12 times 5, minus 3 times 12, 5 times 12. Okay, we're left with 4 and 5 over 60 minus 36 over 60. Alright, so we have a problem here already. We're going to end up with a negative number in the numerator. Alright, that's not good. Okay, that does confuse things quite a bit. So in order to deal with that, we need to borrow from the 4. We need backup from this 4. Okay, so if we take the 4 away and we make a 3, that means we've opened up 60 numerator values. Okay, Okay, because remember 1 is equal to 60 over 60. Okay, so if I converted that 4 to a 3, now I can add 60 plus the 5. Some of you might already be a little bit confused, which I am also. It's not the greatest method, especially when we get into subtraction of mixed numbers. However, it does work. So 65 minus 36, what's that?
20.
29?
Okay.
I think so too. So if we get 29 over 60. Yeah, so that's the right answer. So we end up with our mixed number is 3 hours and 29 over 60 as our fraction. All right, so this scenario is not ideal, right? We got into this mixed number issue where we're subtracting. So as opposed to doing it that way, the other way, which again I would recommend, is to just convert these two improper fractions from the beginning. Okay? That's what I would suggest to do. So let me show you that. So back up over here. Okay, so we had the equation 8 and 1 12 minus 4 and 3/5. So if I convert these to irregular fractions from the beginning, I'm going to multiply 8 times 12 and add 1. That will give me 97 over 12. And then I'm going to multiply 4 times 5 and add 3, so I have 23 over 5. Now I have to find a common denominator, so I'm going to multiply this by 5, and this by 5, this by 12, and this by 12. Gives me a large number, but again, using your calculator is not a big deal. And then you can just go ahead and subtract the numerators, leave the denominator as is. You get 209 over 60. And then you can convert this irregular fraction to the mixed number of 29 over 60. Okay, just hold on, guys. So there's the two methods that we can use. All right, we'll take up another couple examples after lunch. Any questions? Okay, thanks.